Section 3.4 is on energy. So the definition of energy is the ability to do work. Okay. There are two different types of energy, kinetic energy and potential energy. So kinetic energy is the energy of motion. Potential energy is determined by the position of an object. So for example, a ball at the top of a hill has potential energy. Because it's just sitting at the top of the hill, it can roll down at any time. And that potential energy is what the ball has when it's not in motion at the top of the hill. Once the ball starts rolling, it's moving. So then that's kinetic energy. Okay. So just remember, potential energy is the energy of motion, and potential energy is determined by the object's position. So another example of potential energy would be something like if you had a spring and you pushed the spring down, the energy that is contained within the spring while you're squeezing it together is also potential energy. Okay, so another type of energy is heat. So heat is thermal energy. Heat is the energy associated with the motion of particles. So the faster the particles move, the greater the amount of heat or thermal energy. So units for energy are the joule. So that is the SI unit for energy and work is the joule. So a joule is symbolized by a capital J. And the joule is actually kind of a small unit of energy. So a lot of times you'll get numbers for energy or work in kilojoules. So you'll need to remember that 1,000 joules is equal to 1 kilojoule. Okay. So one example, just to show you that the units of joule are quite small, is that if you are going to heat a cup of water to make tea, it takes about 75,000 joules of energy. So that would be, so let's convert it to kilojoules. So there's 1,000 joules. So that's going to be in your denominator for every 1 kilojoule. So that means it would take approximately 75 kilojoules of energy to heat water up in order to make a cup of tea. So other units that are used for energy are things that you might be familiar with. Calories, abbreviated CAL. So a calorie is defined as exactly 4.184 joules. So 1 calorie equals 4.184 joules. And 1 kilocalorie is equal to 1,000 calories, which is equal to 1 capital C calorie. So all of the nutrition fact labels that you see show you calories with a capital C. That is actually a kilocalorie. So notice here there's a lowercase c for cal, and this is a capital C. So just remember that lowercase c is a calorie and a capital C calorie is actually a kilocalorie. So that means there's 1,000 calories, lowercase c, for every one capital C calorie. And we'll talk a little bit more about that in the next section, which is going to be on energy and nutrition. Okay, so let's talk about converting between the two energy units. So let's say we need to convert 360 joules to calories. So again, we're going to set this up just like all of our other conversions. So 360 joules is what we're given, and we need to go to calories, lowercase c. And we know that 1 calorie equals 4.184 joules, and this is an exact number, so it does not count for sig figs. So we'll set it up, 360 joules. Okay, 360 joules. And we have joules in our numerator. So in order to get the joules to cancel, we need to put joules in the denominator. So 4.184 joules goes in our denominator, and 1 calorie goes in our numerator. Okay, so we have joules on the top and joules on the bottom, so those cancel, and we're left with calories. So if you do this math with proper sig figs, there are 86 calories in 360 joules. So again, we'll look at the sig figs, but this is an exact number, so it doesn't count for sig figs, so we need to look at the number that we started with. So 360 has 2 sig figs, so our answer needs 2 sig figs, which is what we have here. Okay. And that is it for that section on energy. So the next section will be on energy and nutrition.